Okay, folks, we're just going to go over a few more examples of how to dilate. This should get you through the practice sheet. I've got 4 examples, basically, that kind of match what we were doing. We're going to dilate this shape with a scale factor of 2, so we're doubling it in size, and our center of dilation will be the origin. Okay. Make sure that this is all focused up. It's good. So yeah, 0, 0, make sure that's on there. Yeah, scale factor 2. Okay, so I've got A, B, and C, kind of the points already done. A is -3, -2. B is -4. Shoot, that should be reversed, my bad. -2, 4, sorry. And then C is at 2, and then 6, 2, 4, 6. Yeah, okay, good. So the idea here is we're gonna make this shape bigger. The center of dilation is the origin, so basically it's gonna be expanding out from there, okay? So again, I'll talk about kind of the 3 techniques that we can use for this. A prime, I'm just going to do where we take the original point and we double it, because we are using a scale factor 2, right? This only works, again, if your center of dilation is the origin here. So the idea here is you're just going to take these numbers and double them. So it's going to be -6, -4 once we double it. -6, -4. I might actually, yeah, I'll just grab a highlighter when I'm done. So we'll go left 6 and down 4 for A. So 1, 2, 3, 4, 5, 6, and then down 1, 2, 3, 4. So that becomes A prime. And then B prime, we'll use our other technique right here, which is drawing a line out from our origin through the point, right? So our origin's right here, our center of dilation. We're just going to draw a line that goes through the point that we're trying to dilate. So I'll even just kind of like dash it as we go, right? And so the idea here is that this point, as it expands out, as it gets bigger, or this part of the shape, this point is going to lie on this line, right? And so the idea is it's going to be kind of the same distance. So this and this, if you measured it right here, I mean, we could straight up do centimeters right here. So it's going to be basically 3 centimeters out. We just go 3 centimeters out, and it's going to be right about there. Let me just double check. Over 204. Yeah. Again, not perfect because I'm not a robot, unfortunately, but it's pretty good for the amount of work we're doing here. So that will be at -4 and then +8. Right, and you can see that I could have just doubled that and gotten the same thing. Now for C, the idea here, this is kind of our 3rd technique where we just count from our center of dilation. It is 2 to the right and then 6 up. We can kind of just go 2 to the right and then 6 up again, 2, 4, 6 for that. Or you could just double it from the origin where it would be 4 to the right, 1, 2, 3, 4, and then 12 up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, that's off the grid. Let me do that again. So it's over 2 and up 6. We can just go over 2 and up 6. Or from the origin, we can go over 4 and up 12, because that would be that doubled. So C prime would be 4, 12 right there. Now I'm going to use my straight edge to get my new shape here to here. Okay. And you'll notice that as I kind of like go, like draw a line out from each point, right? This is C prime, by the way. Right? Those lines expand from the origin out through the points. Okay? And so I can see that I have my new larger shape here. It is twice as big. Gosh, that looks good. I like to highlight the new shape just to show that it is different from the original shape. A different color highlighter, right if I did. And it looks like I do not have one super easily accessible. Gosh, that's disappointing. Okay, anyway, that is our first example where we are dilating doing an enlargement from the origin. Okay. Now, similar, we're doing a dilation from the origin to the origin, but this is going to be a reduction. So again, I have my shape right here. We're going to be basically multiplying each point by half or cutting it in two. Okay. So this is going to become 3, 2 for D. 3, 2 for D prime. So over 3 and up 2, D prime. Negative 2, 8 is going to be negative 1, 4. Okay. And then for the last one, let's see, negative 1, 1, 2, 3, 4 for E prime. Now for this last one, it's going to be from our origin. I'll kind of draw that diagonal line out as an alternative technique. So I know it's going to be, somewhere here. And the idea is, since it's left 4 and down 4, it's going to be half that distance. So it's going to be right there, which we can see is directly on that dotted line. So that's going to be F prime right there. Booyah. Oh, this highlighter is running out of juice. Anyway, so that is our smaller shape right there. Yeah, I don't know. It's going kind of towards the origin there, and that's the idea. Oh, F prime, I need to put the coordinates for that. Left 2 and down 2 is negative 2, which is this negative 4 cut in half. Okay, so that's how we dilate, doing an enlargement or a reduction based on the origin, based on 0, 0. Now we're going to alter things slightly, and our center of dilation will change. Rather than the origin, for this one, we're going to have an enlargement from point W. Okay, and so the idea here is that, so unlike this technique when you're dilating from the origin, where you can basically just double the points because it's a scale factor of 2, or cut the points like the numbers in half to get your new points, you cannot use that technique when you have a different center of dilation. You basically just have to count from the center of dilation to the corner on the shape, or to the vertex on the shape, and then count that distance again, right? So we're making this double, right? So I want to double the distance here from W to Y. So it's 4 here. So then Y prime is going to go another 4 out there. So that's Y prime at 0, 10. I did Y first for some reason. 0, 10. And then Z is kind of directly on this line. So it's 4 out. It's going to go another 4. 1, 2. It's 4 left and 4 down. So it's going to be 8 left and then 8 down. 1, 2, 3, 4, 5, 6, 7, 8. So that's our Z prime right there. You'll notice that it's on that same line as well, just like this is. We could draw out to that from W to X, right? And it would give us that line out as well, okay? But W to X, if we just count it, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left. And then 1, 2, 3, 4, 5, 6 down. So 10 left and 6 down, so it would be 20 and 12 from this point, but I'm just going to do another 10 left and then 6 down from X. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then down 6. 1, 2, 3, 4, 5, 6. So that's our X prime down there. Now I'm going to use my straight edge. Do I have both points on there? Yeah, it's kind of getting to the limits of this if I don't want to zoom out, which I don't think I need to. Let's just do that. So we can see this is our new shape right here, right? And instead of kind of like blowing away from the origin, it's actually blowing away from that other point W right there, right? Again, we can draw our lines out like from there to there, or there to there, or right through that X and that X prime if we wanted to, just as a kind of another way to do that. Yeah, there you go. Okay, so that is a reduction from a point other than the origin. sorry, that was an enlargement from a point other than the origin. This is going to be a reduction, because this is less than 1 from negative 8, 6, this point P over here. So the idea here is, again, you can't just divide this in 2. Oh, and by the way, like, your scale factors are not just going to be 2 and 1/2, right? You can have decimals. You can have like 2.5 or 3 or 4, right? Or 1/3, 2/3, things like that. For these first examples, we're just doing kind of some easier examples. Now, just kind of like the idea here is, I know it's going to be shifting this way, like towards that P, I could like draw that line out again. Didn't do it on the last one, so I might as well do it on this one, right? I know that this M, as we shift it closer, is going to be somewhere on this line right here. Now it is up, let's see, 1, 2, 3, 4, 5, 6, 7, 8, and then 2 over. So it's going to be 4, and then 2. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, and then 2. So it should be 4, and then 1. Oh, okay, good. Ooh, I was worried I was going crazy there. So that's M prime right there at, let's see, 1, 2, 3, 4, 5, 6, 7, and then 2. So negative 7, 2 for M prime. L prime, let's kind of use that that line technique to kind of give us an idea of where it's going to be. Okay, I know that L prime is going to be on this line somewhere. I kind of have a guess that it's going to be maybe right there, because it's kind of on that, right? But if we kind of like measure the distance between L and P, right, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 2. So 6 and 1 from this point. 1, 2, 3, 4, 5, 6, and then down 1, and just where I kind of guessed it was going to be. 6 and 1, because that's half of 12 and 2. Again, let's use that line technique to estimate where a point's going to be. My guess is it's somewhere right around here. Okay, so from P to N, it's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8. So 10 and 8 becomes 5 and 4. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Is that right? Yeah, let's see. 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Yeah. Ooh, man. Protractor. It's a little easier to use here. So then L prime connects to M prime, L prime connects to N prime, and then N prime connects to M prime. L prime is left 2 and then up 1, 2, 3, 4, 5. And then N prime is left 3 and up 2. Yeah, I love it when a plan comes together. Yeah, I don't know. Hope that helps, guys.